Hello everyone, welcome to the session, Building Single-Page Scrollable Website with Flutter. You probably guessed my name as Cagatay, but it's actually Cagatay. It's great to be here and share the Flutter spirit and knowledge with you. Let's start with a brief About Me section. I studied telecommunications engineering, but I always wanted to be closer to the end user. That's why I started my professional career as mobile application developer. But nowadays, thanks to Flutter, it's not only mobile application development, but application development, regardless of which operating system we are building for. I have Android development experience for 7 years. I started Flutter development almost around 1.5 years ago, and I'm really extremely happy about it. I was actually hired in the current company that I'm working in as an Android developer, but I switched to Flutter project. I'm really happy. I've been sharing my happiness and learnings in this kind of conferences, writing blog posts, writing articles in Medium. And I love ultra trail races. I miss ultra trail races. Nowadays, I'm training for my first ultra trail race since COVID. I hope I will manage it. Currently, I'm working at Wolt, and using Wolt app, you can order almost anything from restaurants and stores. At Wolt, we have native iOS, Android, React Native, Flutter, and progressive web apps, many technologies. And we have a Flutter app that is used in 23 countries for picking and packing the orders in retail stores. Before starting, I would like to mention that I have a series of articles in Medium and open source demo projects in GitHub account. Navigator 2 and building single-page scrollable websites, these are the names of this article series, but nowadays I'm working on the new one, which is called multi-page scrollable bottom sheet with Flutter, and hopefully it will be published very soon and maybe today with this conference. And let's start with Flutter Web. It's a big topic, and today we will cover two things for building Flutter applications targeting web: scrolling logic with 4 different widgets and navigation with Navigator 2 API. Last year, around July, the Flutter team asked Flutter developers about their Flutter web experience on Reddit. And the main complaints were scrolling is not smooth, app loading time is slow, it supports the hot restart but misses the hot reload, which is really important for Flutter developers. That's why we love Flutter and Dart. And most importantly for many developers, including me, lack of proper search engine optimizations, SEO, and meta text support. Although there have been constant improvements since that time, some of the complaints are still valid. And according to the 2022 Flutter roadmap, the targets for Flutter Web this year is first, improvements on performance, plugin quality and accessibility, and second is making it easy to embed Flutter apps into existing non-Flutter web projects. I would like to mention that before making a decision on whether to use Flutter Web for your web project, first read the web FAQ on Flutter website. The best documentation for Flutter is Flutter website. It says there that building websites with static content, such as blog documentation, is not recommended. Why? Because Flutter Web is complicated, and Flutter Web is supported to port applications to web. So it's application-centric experience, such as progressive web apps, existing mobile apps, and single-page apps. Today, we will focus on the single-page apps. Let's first talk about what we mean by a single-page scrollable website. In a single-page scrollable website, all the content is on one long scrolling layout that has multiple sections. And visitors can jump between sections by clicking on the sticky menu buttons, like either on top or on the side. Let's see the requirements of the demo app that is available in my GitHub page. The first requirement is clicking a button in the navigation we will scroll the page to the corresponding section. Here you see the top navigation, sticky navigation, and when button is clicked, it is scrolling programmatically to the corresponding page. Second requirement. The address bar will be updated according to user interaction. Here you see the buttons on the sticky menu is clicked and the browser address bar is updated, but also as we scroll in the page, the address bar is also updated. Third, the web browser backward and forward buttons will work according to the browser history. Here we click multiple buttons and we create a browser history here, and then when you press back and forwards, the pages are displayed according to the order in the browser history. And entering the URL on the address bar will open the corresponding section. Here we write the color code, and when the app is launched on the web browser, it will jump to the corresponding section. And now we also add the shape type. Now it will show the dialog of that section. Finally, entering an invalid URL will show the error page. Here we write square, which we don't know, we don't show that dialog, and then we have the error unknown page. Okay, scrolling logic. In this section, we will implement the scrolling logic using 4 different Flutter widgets. And for each widget, we will talk about 3 things. 1, performance. 2nd, listening the user input and scrolling to the target section in the single page. 3rd, scrolling in the single page and notifying the browser address bar and the buttons in the sticky menu. A scroll view consists of 3 elements. A scrollable widget, which recognizes user gestures and implements the scrolling logic. 2nd, a viewport widget, which is the visible box, and it displays only a portion of list items. And finally, slivers for scrolling effects, which we don't cover in this talk. When we talk about the performance of a scroll view, we ask these questions. Are the list items built, laid out, and painted lazily or at once? But what is lazy loading? Lazy loading is building, laying out, and painting only the items in the cache area of the viewport. So here in the screenshot on the left, all the items are present at once, and on the right, only the list items that are in the cache area are shown, because it's lazy building. So you see all the items here and only 2 items. So in the single page demo app, we listen for selected color code updates and scroll to the corresponding section. And Flutter provides pixel-based scrolling instead of index-based scrolling. As a result, when we want to programmatically scroll to a section, we need to provide target scrolled section in pixels. And there is a problem here. So what is the problem here? The problem is with lazy loading. When we load list items lazily, we only lay out the items in the viewport's cache area. Now, let's say that we want to scroll to a section. And what do we need? We need the size information of the sections that are previous than the target section. And the rule is simple. Flutter framework works in a way that we can't know the size of the widgets before laying out. It's lazily, so not everything is laid out. As a result, we can scroll to a position of the target section. And what can we do? We have 3 options. 1, using fixed height list items. 2nd, not lazily loading, which is not preferable from performance point. And 3rd, illusion. We will see an illusion, which we will talk about soon. And what do we want? We want to scroll and notify. So when we scroll, we need to notify the color code listeners. And what are these listeners? The listeners are buttons in the sticky menu bar. As you saw in the demo, we highlight the buttons and then we update the browser address bar. So we will scroll and inform the listeners, notify the listener. And Flutter framework provides us notification listener, which emits notification. And as the user scrolls, the notification listener will send us a notification which has the pixel value. And But we have the current offset information in this notification, but again the problem is finding the index of the section within the lazily built scroll view, because we don't know the sizes of the items that are not yet laid out. Now let's start with the first scroll view we used in the demo app. It's lazily built list view with builder constructor. Here our constraint is that we need to use fixed height list items, and in this case listening the target section updates and scrolling to the target section is quite easy, because we know the index number, we know that all the list items have the same height, and the target offset can be easily calculated by multiplying the index by the fixed height. And notifying the listeners according to the scroll positions change is also straightforward, because the scroll notification tells us the current scroll position. We divide the position to the fixed item height and get the index. Then we notify the listeners. The second scroll view widget used in this demo app is the page view. Page view is like a list view, but it is more tailored for items of equal size. Again, we will lazily build the page view with builder constructor. Here we will also set the page snapping off to lock the sections during the scroll gesture. And obviously the axis is vertical here. So in a page view, each section is called a page, and its size is by default equal to the viewport size. Page view has a page controller that lets you programmatically scroll to an offset in terms of viewport size. So you can programmatically scroll to a page using an index number, which is exactly what we want. We want to the section, we know the index of that section, and we will just call that page controller dot jump to, or what was the okay. Yeah, page controller extends the scroll controller and handles browser window resizing better than scroll controller, because, as I said, it is tailored for items of equal size. By default, each page has the same size of the viewport, and if we want to change the size of a page, we simply provide viewport fraction to the page controller. Let's say that our requirement is to have a page with a minimum height of 800 pixels. And when we resize the browser, the viewport height, let's say, became 400. So in this case, we provide a new page controller with the fraction equal to 2. Again, similarly here with page view, we have lazy build advantage. Since it is tailored for items of equal size, calculations for finding the trailing index and scrolling to index is much easier. So it was not jump to, animate to page. So with animate to page, we scroll with animation. With jump to, it instantly jumps to the section. And but yeah, the disadvantage is that it has to be fixed height. All the pages have the same height. And when we get the index number from the sticky menu button clicks, we can easily scroll to a page on a page controller using the index number. We can again listen the user scroll notification, and when a notification is emitted, we can get the current page index from page controller easily and then notify the listeners, because page controller directly gives the page at any time. The third scroll view widget used in this demo app is single child scroll view with a column. And in this case, all the list items are built at once. It's not lazy building. So we can do all the calculations easily because we have the size information of all the items after the first frame, after they are laid out. But the bad thing is, as it is obvious, the performance, because we build all the items no matter they are visible in the viewport or not. Okay, now let's see how we scroll to a section in this widget. We will first create a list of global keys. And for each section, when the state object of the stateful widget is created, we will provide these global keys to the pages. So each section is a widget which has this key, global key. And after all the items are laid out, and starting from the next frame, of course, we will start listening this color code index. And when the index changes, we call ensure visible static method using the context field of the target section's global key here. Now scroll and notify the index. Let's see how we notify the new section as we scroll in the page. Notification listener again emits the user scroll notification on scroll event. Then we get the current offset from the scroll notification. Here, inside the for loop, we iteratively compare the accumulated height to the current offset because we have the global keys of each section. And in the end, we find out which section is the current offset belong to because we accumulated the heights from the beginning through the global keys, and global keys has the context and context has the size information. The final scrollable widget we will talk is scrollable positioned list. This is where the illusion happens. Using this widget, we can lazily build the list items and they don't have to be fixed height. This is the best part. This widget enables scrolling by index instead of scrolling by pixel, which is exactly what we want. And the disadvantage is that it is not provided by Flutter framework. It's a package developed by Google developers who are not actually in Flutter team. As a result, it's a dependency to the project in the end, and we have to wait for bug fixes, updates. I must admit I waited for almost a year to get this fix while implementing this demo project. Actually, I didn't get the fix, but I forked the project. I applied to fix myself. But yeah, currently it has the fix anyway. Another disadvantage that it is not actually a standard list view. It doesn't expose a regular scroll controller because it's not regular list view. And the problem here is that we need scroll controllers with for scrolling animations using slivers, for example. And this widget provides very clever solution, like an illusion, as I said. It enables index-based scrolling and lazy building with this illusion. So what is this illusion? If the target is out of viewport's cache area, a new secondary list is created on top of the current one. And the scrolling is started synchronously in both lists. As the offset gets closer to the target section, the newly created list fades over to the old list and becomes fully visible. So the illusion is like this. It starts both scrolls with the same speed synchronously. The first one, the primary list, fades out, and the new list that we created fades in and then becomes fully visible. Here, scrolling to the target section using this widget is very easy because, as I said, scrolling is index-based. And to notify the section changes as user scrolls, we can again listen for the scroll notification. In the documentation of this package, there is an example on how to calculate the trailing index. And each time we receive the notification, we do this calculation and notify the listeners. And in this case, again, the listeners are the buttons and the browser address bar. Okay, second part. Navigator 2 API. In my opinion, Navigator 2 API is so underrated. Let's give it some love in our remaining time because I think it's powerful. And as Flutter developers, we should really not resist on not using it. We should use it in our apps. It's powerful. Well, I think the best summary of Navigator 2 API is given by Michael Goddard. So it introduces two things. A declarative API like Flutter way. A declarative API to set the history stack of the Navigator widget. And it introduces a router widget to configure the Navigator widget based on two things. One is upstate and system events. Navigator 2 API was one of the most controversial APIs of the Flutter framework because, well, in my personal opinion, the real reason why people found this complicated because when it was introduced, there wasn't enough tutorial and it looked like really complicated. But I was one of those people who thought this is really like overly complicated, not really good for Flutter. And then after diving into the source code and some issues on GitHub, many resources, I came up with this series of articles. I really learned and loved this API. I think it is powerful and I volunteer to advocate it. Okay, why I love it? Because first of all, it's more Flutterish. It means that we build the navigation stack like we build a stack in a declarative way in the widget tree. But Navigator widget itself is a widget. It has a stack and an overlay. So yeah, it's very Flutterish, Navigator 2. Second, separation of concerns. We should not push and pop roots. We should not push and pop roots in different parts of our apps, like show dialog or go to this page in any widget it can be. Instead of this, we have this router delegate, and it's a central place where we create navigation stack. And like when we call show dialog, for example, we actually push a dialog route to the Navigator widget, like implicitly. It's very imperative. Well, in the demo app, I don't call show dialog, for example, to show the dialog, but I add the dialog route to the navigation stack in a declarative way. Finally, I personally believe that a Flutter web UX without Navigator 2 is really bad because you cannot update the browser address bar. Yeah, that's really bad. Let's start from the beginning, like the root. What is a Navigator widget? Navigator widget manages the routes in a stack discipline. It has an overlay widget. Every route in the Navigator widget has its own overlay entry set. And yeah, with Navigator 2, what we do is that we declare the navigation stack, but at the same time, we can still push and pop routes imperatively. So if we want to use Navigator 2 in our project, we don't have to completely migrate in one day. For example, in our current project at Wolt, we migrated to Navigator 2, but we still imperatively push and pop some pages. Navigator widget existed before the introduction of Navigator 2, but the router widget is introduced with the Navigator 2 API. It is the brain of the new navigation system. And the router widget actually orchestrates the navigation system based on system events and upstate changes, but it delegates the responsibilities. We have router delegate, route information parser, route information provider, back button dispatcher. Each has different responsibility, but centrally managed by the router widget. And we have route information, very important for web apps. Route information holds location and state information of a route. And the location field is a string, and it is equivalent to a web URL. Route information flow is two ways. It is between the engine layer and the framework layer. Like we should really note that there is this browser history and then navigation history. They are different things. Browser history is in the engine layer, and navigation history is in the framework layer. And the flow happens, like there are two flows between this router and the engine, framework layer and the engine. In the first flow, we enter a URL in the browser address bar, and then router widget receives the new location from the web engine through the route information. And in the second flow, when the app state changes, for example, because of a user interaction, and router widget passes a URL to the engine layer using a route information instance. Configuration, difficult part. Router widget configures the Navigator widget according to app state changes and system events that we said. But the configuration is the keyword here. And in our case, for example, we have this single page app configuration. It is just a data class and used by router widget in navigation operations. We will see soon how we use this. Well, this is complex because in our app, we have single page app. It is very simple, so it is easy to define this configurations here that represents the app states. But when the app gets complex, it might be a bit difficult to define different configurations. Let's now analyze the first flow from Flutter engine to the framework. So Flutter engine will pass a URL with a route information. What happens? First, the route information provider gets the location and the state information from the browser history. And then this is mapped to the route information. The route information provider passes this route information to the router widget, and then the router widget passes it to the route information parser. The route information parser parses the route information and passes a new configuration back to the router widget. Then the router calls the set new route path in router delegate, which keeps track of the app state. And then the app state is here internally updated. And finally, router widget asks the router delegate to build a new navigator, and the router delegate returns back the navigator. Let's see here, for example, route information parses the route information, it parses and then returns a configuration to the router widget. Here you see that first we check the path segments. If the path segment number is 0, then it's the home page without a selected color and shape. If it has more parameters, then we parse them and then we get the selected color and shape. And after receiving the configuration from the parser, the router widget sends this configuration to the router delegate through this set new route path method. Here, the router delegate updates the internal app state, and then router widget asks the router delegate to give a navigator. So we have these states, and then depending on the states, we provide a list of pages. So this list of pages is actually the navigation history. And now let's see how the framework passes the route information back to engine. The router widget here first asks the router delegate the current configuration, which is the representation of the current app state. And then router widget passes this route information passes this current configuration to the route information parser in restore route information method. And then configuration here is mapped to route information, and this route information is sent back to the Flutter engine by route information provider. Here we see this current configuration, and we have two configuration possibilities here, home or unknown. And the current configuration is sent to the route information via the router widget. Finally, this is the last slide, almost last. Configuration is mapped to the route information here within the restore route information method inside route information parser. And in the end, the configuration is mapped to the route information and sent back to the engine. Okay, too complex. What is next? Yeah, I can imagine this has been too complex, but in community we are very lucky that we have great packages which simplifies the Navigator 2 implementation. I personally didn't need to use any of these packages, at least not yet, because we have been implementing Flutter. We have been implementing our app with Flutter only for mobile app. Maybe when we add the web, it will be more difficult. Not difficult, but complex. So yeah, maybe we will need a package. But here, there is this Go Router package by Chris Sells. It has gotten really quite good attention from the community. Chris is actually one of the most talented Flutter developers in the Flutter team, but soon he is leaving Google. But his package, this Go router, will be published and maintained by the Flutter engineering team. So this looks a bit promising. If you find Navigator too complicated, you can try this package or the other packages. And that's all. Thank you very much. This was too much information maybe for many of you, but maybe when you watch this again, you can get this idea behind Navigator 2 and single page scrollable website. Please read my articles and check the demo project in my GitHub page.